In this tutorial, we're going to talk about C programming structure. Before we study the basic building blocks of the C programming language, let us look at a bare minimum C program structure so that we can take it as a reference in the upcoming lessons. A C program basically consists of the following parts: preprocessor commands, functions, variables, statements and expressions, comments. Let us take a look at the various parts of the above program. The first line of the program, $stdio.h, is a preprocessor command, which tells the C compiler to include stdio.h file before going to actual compilation. The next line in main is the main function where the program execution begins. The next line /*/ will be ignored by the compiler, and it has been put to add additional comments in the program. So such lines are called comments in the program. The next line printf is another function available in C, which causes the message "Hello, world" to be displayed on the screen. The next line returns 0, terminates the main function and returns the value 0. Compile and execute C program using a command line. Let us see how to save the source code in a file, and how to compile and run it. Following are the simple steps. Open a text editor and add the above mentioned code. Save the file as hello.c. Open a command prompt and go to the directory where you have saved the file. Type gcc hello.c and press enter to compile your code. If there are no errors in your code, the command prompt will take you to the next line, and would generate a .out executable file. Now, type a.out to execute your program. As shown in the example, you will see the output "Hello World" printed on the screen. Make sure the GCC compiler is in your path and that you are running it in the directory containing the source file hello.c. Time to write C programs. This demonstrates the effect of the postfix increment expression. The only difference in the printouts between previous example and this example is the use of the increment operators. The first program uses the postfix increment. The second uses the unary prefix increment. In both cases, we start with the same value for A, and it has the same value at the end, but the value of the expression itself is different. To help remember the difference, use this rule: if the ++ is before the operand, the increment takes place before the expression is evaluated. If it is after the operand, the increment takes place after the expression is evaluated. This simple program requires only 3 explanatory comments. 1. Note that even for a simple program, we include all the standard documentation comments. 2. We do not recommend that you include calculations in print statements as we have done in this program. It is not a good structured programming technique. We include them in this program because we haven't yet shown you how to save the results of the calculations. 3. Study the format string. To print a %sign as text in the format string, we need to code two %signs. Note that we have used an assignment statement in the printf statements to demonstrate that an assignment expression has a value. As we said before, this is not good programming style, but we use it here to match the format we used in the previous example. Do not hide calculations in print statements. Also, since we are changing the value of x with each assignment, even though it is in a printf statement, we need to reset it to 10 for each of the print series. Several in this program require explanation. First, as we stated before, it is not a good programming practice to code an expression in a print statement. We do it in this program, however, to demonstrate the promotion or demotion of the expression. The first print series displays the value of mixed type expressions. As you examine each result, note that the value printed is in the form of the higher ranked variable. For example, in statement 15 the boolean and the expression b is promoted to a character, and then added to the value of the character expression c. The result is the character b, which is then passed to the print function where it is printed using the format specification %c. The second print series displays the results of assignments. In the first one, we add true 1 to the letter A. The result is B as you would expect. In the second assignment, we add the letter B from the previous assignment to a real number. The new value of the real number is almost 66 greater than the original value. The difference occurs because real numbers are now exact. Rather than storing 245.3, the value stored was 245.299988. Finally, note what happens when we assign a negative real number to a boolean. The result is true. And that wraps up this tutorial. Thanks for watching. Stay tuned for more.